Now what I'm doing is fitting my rectifier board, which I bought on eBay for $17. Some assembly required. We've got 20,000 microfarads in each leg of the plus and minus. It outputs about 20 volts from this transformer. That's going to be regulated down to 15 volts at up to 3 amps to drive the deflection amplifier board. This board is also a rectifier filter, low power. This so far will power the focus coil in the camera. The positive side of this will be tapped and run to a 12 volt regulator for running the high voltage power supply for the image dissector tube. So the output of this will be plus and minus 15 volts high current, plus and minus 15 volts low current, and plus 12 volts so far. And that's the goal. So we have to turn this around. You can see here the 4 screws, the transformers right here, and I need about 1 finger's width out from it of clearance for this board to sit right in front of the transformer and be cleared. Actually, it's fine right there. Okay? So, looking down from the top is squared up. This board will sit right next to him. Goes right there. Okay. So, we get the pen. I think it's leaving a mark. The little pen. That's 1. Oh, come on. Right there. Yeah. Alrighty then. Let's see. We need to deburr these holes. Good. Now we install the standoffs. Let's see. Is that how you want to do it? No. Do it this way. Alright. Alright. Now, on the bottom we have nuts, captive washer nuts, and on the top we will take screws. And you still can't see it. Okay, first I'll put the large board in. I hope it's not too close to the transformer. It's not. Here we go. The first one's easy. There's always one that's not in alignment. It's a Murphy's Law. What's going on here? screwdriver's magnetic. It picks up all kinds of garbage off the tabletop. Nailed it. What do you know? That means I can tighten the nuts on the back for this one. There's a wild one. It's out of alignment. What you do after you've drilled your holes this crude way of measuring, you install the screws on the top, snug them down. This is placing all manner of force because things aren't exactly lined up yet. And the force is being transferred to the aluminum box, which is of course warping in response. And it's amazing how bad it looks when you finish the project. The box actually doesn't look square. And this only matters to people with OCD, by the way. Like me. Alright, so now we turn it over. And using our nut driver, we loosen all the nuts. And release the stress. They were never very tight. That was so that when I put the screws in, they had some play. Now I will tighten them down. So these four are the first large board. And when I tighten them across corners. And then across the short end, and then the long end. And don't twist these too tight. You will snap the threaded portion right off of the standoff. Now everything is nice and tight. Our power supply is nearly complete. Nearly, but not completely. Oh dear, I just realized I probably have to cut some holes here. We'll see how that works out. I don't think it'd be that bad. But we've reached an interesting break point. The secondary wires will tie first to this board and then to this board. Time to connect the wires. I'm going to try to do my strip the wire in the middle trick. Open up the gap. Don't know if it's cut through or not yet. I got to do this without ripping the lead out of the transformer. Alright, now, right here I'm opening a gap. I need to get about 1/4 of an inch, maybe a little more. Like that. Can you see it? I got to do that 2 more times. Now, same deal. I cut the insulation carefully. You don't want to cut into the wire and break conductors. Then the wire can't carry as much current. What I'm doing is I'm making a loop here and pushing down so there's no force being transferred from here into the transformer. Nothing's pulling on the transformer. Okay, it's okay. What I'll do is tin it. This will hold everything together. May as well do that one while I'm here. Put on my magnifier. Or zinc, as the case may be. Alright, there we go. Another opening. We'll tin it. Because I did nick it. There we go. Now down on the power supply board is this terminal strip. I'm going to pull the screws all the way out first, lay the open end of the wire in there, and then put the clamp back down. This allows the conductor to pass through and be connected without breaking the wire and increasing the resistance. Alright, now I definitely want that loop. I like strain relief. Alright, now put our screw back. If you're doing this one, then it'll be for the next one. Alright. Okay, got the bundle of 3 that looped through. You have a loop on the transformer, loop on the transformer. And now these will come up and over and right down to there. Look at that. And the folks who sold me this board for $13 on eBay, fully assembled, even included the 2 plugs to hook the sucker up. What a deal. The large rectifier board with the 20,000 microfarads of capacitance compared to this board's 220 microfarads. This board was $17. It's made for hi-fi analog amplifiers. It's going to work for my camera beautifully. Okay. These pins are made like razor blades. They're made out of a ribbon of steel or brass. I believe this is brass. That is then run through a series of dies which fold it up into a pin shape. After these are installed on the wires, then they'll slip into this little shell, which will then plug onto this connector right here. Alrighty. I don't have the crimping tool for this, so I have to fake it and do this very laboriously with needle nose pliers, folding over these little tangs that attach to the wire and the tangs that grab the insulation. And for me, nothing is connected until it's soldered. If I pulled on that, it would come right off the wire right now. So I am going to solder it on. I don't think it's going anywhere. The center tap of the transformer goes in the center of the connector. The being AC, the other two don't matter at all. Alright, like that. Crimp it in a little tighter. There it goes. Alright. Hope it reaches. Ta-da! AC is now completely wired. The AC side of this power supply is completely wired.